a common thermoplastic polymer that made from ethylene monomer. So it is abbreviated as PE, and it is a lightweight, durable synthetic resin that has a variety of uses. It is also most commonly used plastic. The chemical formula for polyethylene is C2H4. The application of polyethylene is medical device, plastic bags, toys, kitchenware, and so on. Types of polyethylene. The first one, low density polyethylene, LDPE. Highly branched structure, flexible and transparent. Second, high density polyethylene, HDPE. Linear structure, high strength, moisture. Third, linear low density polyethylene, LLDPE. Less branching than LDPE, tough yet flexible. Next, ultra high molecular weight polyethylene, extremely long chains, highly durable, wear resistant. Next, medium density polyethylene, MDPE, intermediate density, good toughness and chemical resistant. The last one, cross-linked polyethylene, PEX, cross-linked structure, improved heat and chemical resistance.
Next is bulking polymerization. Bulking polymerization refers to a polymerization process where the reaction takes place in the absence of any solvent or dispersing medium, using only the monomers and the initiator if required. When applied to produce polyethylene, the process involves the polymerization of ethylene monomers under a specific condition. These are the steps of bulking polymerization. First is monomer input. Ethylene gas is the primary monomer used in polyethylene production. High purity ethylene is introduced into the reactor. Second, catalyst system. Catalysts such as zinc granate catalyst, Phillips catalyst, or metallocene catalyst are added to initiate the polymerization reaction. The choice of catalyst determines the molecular weight, branching, and overall properties of the polyethylene. Third, reaction condition. The polymerization typically occurs at high pressure at 1000 until 3000 atmosphere and elevated temperature starting from 80 to 300 degrees Celsius, especially for high pressure methods like free radical polymerization. In low pressure methods, conditions are milder and catalysts are more efficient. Next is polymerization process. Ethylene monomers react to form long polyethylene chains. This isothermic reaction releases heat, required efficient cooling to maintain stability. Next is polymer formation. As the reaction proceeds, polyethylene precipitates out as a solid or viscous liquid due to its high molecular weight. No solvent is present, so the polymer is formed in its bulk phase. And lastly is post-processing. The polymer is collected, separated from the catalyst residue, and further processed. Additives such as stabilizer and antioxidant might be added to enhance the performance. The polyethylene is then pelletized for easier handling and transport. These are the advantages and disadvantages of bulking polymerization. The advantages of bulking polymerization is simplicity of operation, high purity product, and fewer steps for purification, while the disadvantages is heat control is challenging and risk of thermal degradation or runaway reaction.
Hi, it's me Atiqah. Next is what is suspension polymerization. Suspension polymerization is a heterogeneous radical polymerization process that uses mechanical agitation to mix a monomer or mixture of monomer in a liquid phase, such as water, while the monomer polymerizes, forming squares of polymer. For example, ethylene gas is mixed with water, forming small droplets of the monomer suspended in the water. This polymerization happens inside these droplets, turning ethylene into polyethylene. Next is suspension polymerization process. The first step is preparing the mixture. Ethylene gas is added to a large reactor. In the reactor, water is used as the continuous phase, and the ethylene dispersed into tiny droplets. A special chemical called an initiator is added to start the reaction. Step 2. Polymerization in droplets. The initiator breaks down and starts the polymerization process. This causes the ethylene molecules inside each drop to bond together, forming a long chain of polyethylene. This process happens under high pressure and heat. The third step is polyethylene particle formation. As the polymerization continues, the ethylene droplets transform into solid polyethylene particle. These particles are small, round and uniform in size. Lastly, separation and cleaning. Once the reaction is complete, the polyethylene particles are separated from the water, then washed and dried to remove any leftover water or chemicals. There are three advantages suspension polymerization. The first one, high purity. The polyethylene produced is clean with very few impurity because the reaction takes place inside the droplets, minimizing contamination. The second one, control over particle size. The process allows precise control over the size and uniformity of the polyethylene particles. Lastly, high yield. The process is efficient and capable of producing large quantity of polyethylene. Next, I will pass to Sabrina to continue this presentation. Next is suspension polymerization process. The first step is preparing the mixture. Ethylene gas is added to a large reactor. In the reactor, water is used as the continuous phase, and the ethylene dispersed into tiny droplets. A special chemical called an initiator.
For immersion polymerization is not commonly used for the synthesis of polyethylene due to the high reaction temperatures and pressures typically required for its polymerization. Instead, polyethylene is usually produced through high pressure radical polymerization, low density polyethylene, or catalytic methods like ELIANA or metallocene catalyst for high density polyethylene and low density polyethylene. So here's immersion polymerization methods. Immersion polymerization is a process that uses an aqueous medium to polymerize monomers. So the components include monomer, in this case ethylene gas, not a typically candidate for immersion due to its low solubility in water. Other than that, water acts as the continuous phase, and surfactants stabilize monomers, droplets, and growing polymer particles. Lastly, it's an initiator, often water soluble, like porous sulfates, to create radicals in the aqueous phase. So immersion polymerization has its advantages such as environmental benefits. It reduces reliance on organic solvents compared to traditional method. Other than that, size control, it improves control over particle size for specialized polyethylene grades. Lastly, it's energy efficiency, which potentially lower energy cost due to heat dissipation in water. Although immersion polymerization is promising for other polymers like PVC and styrene butadiene rubber, it is not a standard method for polyethylene production due to the challenges outlined above.
Next, gas phase polymerization. What is gas phase polymerization? Okay, gas phase polymerization is an industrial process used to produce polymers such as polyethylene. This process primarily uses gaseous monomer like ethylene or propylene, which are polymerized under controlled conditions in a specialized reactor. Okay, so now let's get detailed process of gas phase polymerization. The first one is introduction of monomer. This process begins with the introduction of gaseous monomer into the reactor. For polyethylene production, ethylene gas is the main monomer, and other co-monomer like butane or hexane may be added to tailor the properties of the final product. Second, catalyst activation. A catalyst is aided to initiate the polymerization reaction. Common catalysts include zigzanata, metallocenes, or chromium-based system. These catalysts play a crucial role in ensuring the polymerization process efficiently. The third one is polymerization in a FIRDAUS bed reactor. The reactor typically operates as a FIRDAUS bed system. Here, a stream of gas flows upward through a bed of polymer particles, keeping them suspended and well mixed. This ensures uniform temperature and reaction conditions, which are vital for consistent polymer quality. Next, polymer growth. The ethylene gas reacts on the surface of the catalyst, forming long polymer chains. As this chain grows, they precipitate into solid granules. The granules accumulate in the reactor while the gaseous monomer continue to circulate. Next, granule extraction. Once the polymer granules reach the desired size, they are removed from the reactor. Fresh monomers and catalysts are continuously fed into the system, maintaining steady production. Next, recycling of gases. Unreacted monomers are separated, purified, and recycled back into the reactor. This minimizes waste and enhances process efficiency. The last one is post-processing. The extracted polymer granules are dried, cleaned, and may be blended with additives or stabilizers. They are then pelletized for ease of transport and further use. The advantage of gas-phase polymerization, the first one is efficiency. Continuous operation allows for large-scale production. Second, scalability, easily scalable for large-scale production. The third one is product quality. Enable precise control of polymer molecular weight and density.
This is solution polymerization. Solution polymerization is a process used for polyethylene production, where the polymerization reaction occurs in a solvent that dissolves both the monomer ethylene and the resulting polymer. It is typically employed to produce low-density polyethylene and low-density polyethylene. Here are the solution polymerization process. First, it's a raw material. Ethylene is the primary monomer, often combined with comonomers such as 1-butene and hexane for LLDPE production. Next, the solvent. A hydrocarbon solvent such as hexane, cyclohexane, or toluene is used to dissolve both the monomer and the polymer. Next, catalyst. Zigzag, chromium-based or metallurgy catalysts are used to control the molecular weight, density, and branching of the polyethylene. Lastly, reactor. The reaction typically occurs in a straight line reactor or loop reactor under moderate pressures, 10 to 50 atm, and temperatures 150 and 250 degrees Celsius. Next, it's polymerization. Ethylene reacts in the presence of the catalyst, and the solvent maintains the polymer in a dissolved state, ensuring a homogeneous reaction. Number 6 is separation. The polymer is separated from the solvent and residual monomers, often using evaporation and filtration. Lastly, it's recycling. The solvent and unreacted ethylene are recycled back into the reactor. Here are the advantages and disadvantages of solution polymerization. For the advantages, it's good heat dissipation. The solvent aids in dissipating the heat generated during the exothermic polymerization reaction. Other than that, its molecular weight control. Solvent and catalyst interaction allow better control over polymer properties. Lastly, high purity. Solvent washing can give cleaner polymers with fewer impurities. For the disadvantages, its solvent handling requires additional steps to recover and recycle the solvent, increasing costs. Other than that, its environmental concern. Solvent emissions need strict control to prevent environmental impact.
Hi, it's me again. Next is comparative analysis of polymerization method. Hi, it's me again. Next is comparative. As we can see from the table, each polymerization method offers distinct advantage and is suited to be specific application. Suspension of polymerization is often the most efficient and scalable, with excellent control over polymer properties, making it ideal for large-scale production of HDPE. Gas phase polymerization also excels in scalability and control, but solution and emulsion method offer better control for specialized polymer types at a higher cost. Bye. Next, I will pass to Nasirah to continue our presentation.
There are several applications of polyethylene. The first one is construction, such as parts, fitting, and insulation method. Okay, the second one is packaging, such as films, bags, and containers. The third one is the consumer goods, such as household items, toys, and industrial products.
Based on this, we can conclude that gas-phase polymerization is the dominant method due to its environmental friendliness, cost-effectiveness, and scalability. Then, solution polymerization is used for producing specific grades of polyethylene with unique properties, while bulk polymerization is mainly used for LDPE but requires sophisticated heat management. And lastly, suspension and emulsion polymerization are less practical for polyethylene due to technical and economic constraints.